All right, today we're going to start Unit 3, Lesson 3, Day 1 of that lesson. We're going to spend 3 days covering this lesson, 3.3. So we're going to start off with just simple imaginary numbers. So if you look at this graph, this parabola, the thing that's missing from this graph is that there are no x-intercepts, right? This graph will never touch the x-axis, so there's no solutions, really. And what we would say is there's no real solutions. And up to this point, that has been the best thing you could have said. That was the correct answer that we would have accepted. But to overcome this problem, we have created an expanded system of numbers, and we use what we call the imaginary unit. And we use that lowercase I to represent that. Okay? So I is equal to the square root of -1. So think about this. The square root of -25. There is no number that we can say times itself would equal 25, right? Because 5 squared would equal 25, and -5 squared would equal 25. So the square root of 25 would be both 5 and -5. But the square root of -25, there is no number that fits that. So we've got to get a little creative. So what we can do is think of it this way. The square root of -25 can be rewritten as the square root of 25 times -1. And we know from our radical rules that we can break that apart into the square root of 25 times the square root of -1. Now, I do know that the square root of 25 is 5, and I just learned or covered that the square root of -1 is I. So this would simplify to 5i. All right, and what's cool about I is there are some really interesting things that happen when you multiply some i's together. Right, so I to the first, well, that's obviously just going to be I. Anything to the first power is itself. But things start to get interesting when you multiply some i's together. So I squared, in other words, I times I, is going to be -1. Think about it this way. If I is the square root of -1, if we square that, it's like the squared and the radical sign disappear or cancel out, and all we're left with is what's inside the radical, so -1. I cubed is going to be the same thing as I to the first times I to the second, so -1 times I. So that's going to be -I. And I to the fourth power is going to be the same thing as I squared times I squared. So in other words, -1 times -1. So that's going to be a +1. These are real -1 for I squared and +1 for I to the fourth. Now, what's fascinating is the fun doesn't stop there, right? I to the fifth power, if you think about it, that's the same thing as I to the first times I to the fourth. So that's 1 times I, so that's going to be I. I to the sixth, that's the same thing as I to the second times I to the fourth, so 1 times -1, so that's -1. I to the seventh, well, that's the same thing as I to the third times I to the fourth. So that's going to be -I. And then we have I to the eighth. That's going to be the same thing as I to the fourth times I to the fourth, which is 1 times 1, which is 1. So you'll notice that this pattern just repeats itself over and over and over again, and it repeats itself infinitely forever. So what we can do is we can actually derive a rule. We can take the power that I is raised to and divide that by 4, and then whatever the remainder is, the numerator of the remainder is going to be the power it's raised to, and if there is no remainder, then we'll raise it to the power of 4, the fourth power. All right, so I to the 99th, so we take 99 divided by 4, and that gives us 24 3/4. All right, so then we can take this 3, that's the power that we're going to be raising it to, so that's going to be the same thing as I to the third power. And so that means that this is going to be equal to negative I. I to the 134th. So that's going to be the same thing. We just do 134 divided by 4. So let's see here. 134 divided by 4. So that's 12. That's 14. 4 goes into 14. 3 times 4 is 12. Got 2 left over. So remainder of 2. We could just say remainder of 2. Or 2/4 or 1/2. But our answer is 33 with a remainder of 2. So this remainder is going to be the power. So it's going to be equal to I squared, which is the same thing as -1. All right, so where we're really headed today is this next part, the square root of a negative number property. All right, so if r is a positive real number, then the square root of negative r is going to be equal to I times the square root of positive r. In other words, if I need to take the square root of -3, I can take that negative out of the radical and leave it as an I outside the radical and make that I times the square root of 3. All right, and by that same rule, if I square both things, what I end up with is the negative of the thing that's going to be inside the radical. So I square root of 3 squared is the same thing as I squared times the square root of 3 squared, which is the same thing as I squared times 3, which is I squared is -1. -1 times 3 is -3. All right, so square root of -36, square root of -36, first thing I'm going to do is take an I out, and that leaves me with square root of 36. Now I do know that the square root of 36 is 6, so that leaves me with a 6i, and that is my final answer. So next I have the square root of -28. First step, take the I out, leaves me with square root of 28. Then I'm going to split that 28 up into the square root of 4 and square root of 7, because 28 is divisible by 4. It's the biggest perfect square that is divisible by. And the square root of 4 is 2. So we have 2i square root 7. 2i square root 7. Next we have the square root of -32. So we pull an I out, and we can divide 32 up into 16 times 2. So that becomes 4i, square root of 16 is 4, square root of 2. All right, we've got some more simplifying to do, and this time we've got some coefficients. Remember the coefficients that are in front. Any whole number that we can pull out that we've simplified, we can multiply with that coefficient that's already there. So that 2 that's there, we can't do anything with it yet, but we're going to bring an I out. And that leaves us with the square root of 72. Now, square root of 72, that can be broken up into the square root of 36 times the square root of 2. And I do know that the square root of 36 is 6. Now, the communicative property of multiplication tells me that I don't have to multiply things in the order they are written. I can multiply around things or over things. So 2 times I times 6, really I can just do 2 times 6 to make that 12. I, and then I still have the square root of 2 there with it. -5 times the square root of -9. All right, so that -5 is still going to be sitting out front. I'm going to bring an I out as well. So then I have that square root of 9 there. Well, I know the square root of 9 is 3, so that's going to be -5i 3. And so -5 times 3 is -15. I is my answer there. Here I have an I already out front, and when I bring out that other I, it's going to be I times I, which is I squared, square root of 27, and I squared is just -1. It's going to be -1 times the square root of 9 times the square root of 3. Well, the square root of 9 is 3, So that's going to be negative 3 square root of 3 is my final answer. And then lastly, this one is one of the more unique ones. Square root of negative 6, square root of negative 15. There's nothing I can do to simplify those other than pull the i's out. And hopefully you remember from your radical rule unit back in Algebra 1 that when we multiply radicals, we multiply the outside numbers together, the coefficients, and we multiply the inside numbers, inside the radicals together. So this becomes I squared, and then 6 times 15 is 90. Now I squared is negative 1, and 90, square root of 90 can be broken up into square root of 9 and the square root of 10, and the square root of 9 is 3, so that becomes negative 3 square root of 10. All right, and that is it for those examples. Now, solving some equations using the square root property will sometimes result in pure imaginary numbers as a solution. Okay, so when I have, I only use the square root property to solve whenever I don't have a b term, right? There's no y to the first term here. So this is where I use the square root property. So the way this works is I solve it very similarly to the way that I solve a linear equation, right? So I'm going to get y by itself. So I subtract 20 off of both sides to get 5y squared equals negative 20. Then I divide both sides by 5 to get y squared equals negative 4. And then I'm going to take the square root of both sides. But since I'm taking the square root of both sides, I need to take the positive and the negative square root of both sides. So that leaves me with y equals positive and negative. I can pull an I out for sure, but the square root of 4 also simplifies, so this becomes positive and negative 2i. So I have two solutions, positive 2i and negative 2i are my two solutions. All right, so we're not there yet on solving the equations with the square root property. That'll come in the next week or so, but hang tight, we'll get to that. But right now, just want to make sure you understand how to simplify radicals with negative numbers inside. So if you have any questions, please shoot me an email or a Canvas message, and I'll get back to you as soon as I can. Have a great